Hello everyone, I am Prem Kumar. Welcome to Olympiads Math Academy. So today onwards, I am going to launch the sequence of videos for Olympiad exam. Particularly, we will focus on IOQM and NMTC exam, right? IOQM registration started, so you have to apply for that. So still 2 months only is there. The cross course going to start Olympiads Math Academy. So just for 3,999 only up to November. Okay, you can utilize this. You contact my number. The number will be available in the banner. Okay, so let's get started today. Combinatorics topics, counting principle. The first one is the multiplication principle and second one is addition principle, right? So let us take if your task can be done in m ways and another independent task can be done in n ways, right? So then two tasks can be done in m into n ways. So both events happen simultaneously, right? So that is m into n. So when they're asking the and including both events happen at the same time, right? That is and you have to use. So let us take, for example, suppose the 5 students and the teachers wants to arrange them in a row for photograph, right? There are 5 students, there are 5 seats there. So how to arrange them? Okay, you can see arrangements and selection, two cases are coming here. Okay, first let us understand this. 5 student is there, you can see there are 5 places. Among the 5 students, there are 5 places there. First students can be any of the 5 places can be occupied. There are 5 choices for the first person. Second person, if one is occupied, remaining 4 places there, right? Understand? Okay, so that there are 5 places there, right? 1, 2, 3, 4, 5 places there. 5 places there, 5 student is there. The first students can be any of the 5 choices there. Then second student, 4 choices. Third students, 3 and 2 and 1. That is 5 factorial choices there. The 5 factorial is 120 possible ways to arrange them in a row, right? Okay, so whenever they're asking that, you can see the and. So you have to use the, we need the 5 students at the same time. So you have to use the multiplication principle. Okay. So addition principle what? The same idea only. What we can do? So here multiplications, the both events happen at the same time. But addition, both events cannot happen at the same time. That means suppose event A can occur, let us take here. Event A can occur m ways, B can occur n ways. What is the total possible ways either A or B occur? Either A or B occur is m plus n ways. Clear? The first situation is both even happen at the same time. But here both events cannot happen at the same time. That means either A or B. Whenever the or they are using, you have to use an addition. Or means addition and means you have to use multiplications. I hope everyone understand, right? Okay. So let us take more example. Okay. Suppose we have to understand the arrangements and selections, right? The arrangements plus selections we can call as permutations and the selections only we can call combinations, right? Okay. First we have to understand the permutations and you can see combinations, right? This is selections only. This is selection plus arrangements. Selection plus arrangements. Clear? Selection plus arrangements means the permutations, the combination is selections only. Okay. So we already discussed that. Here you can see we already discussed that there are 5 students. So they have to arrange them for photograph in a row. 5 seat is there. The first person can be 5 possibilities, second person 4 possibilities, third person 3 possibilities, fourth person 2 and fifth person only 1 possibilities. You had to multiply because all the events at the same time, you had to multiply all at a time, right? That is 120 ways possible. So the permutations, combinations, what we can do, so you have to, whatever the object is there, you just select it and arrange them. And combination means just selections only. Suppose you can see here, there are n object is there, okay. N object is there, n places there. For example, 1, 2, 3, so on, n object. N places there, n object is there. So first object can be, there are n places there, n ways is possible. Second one, n minus 1. Why we are multiplying? Because we need the both things simultaneously, right? At the same times only is required. Okay. So n minus 1 and then n minus 2. Suppose if the rth event n minus r minus 1, that is n minus r plus 1th term. Okay, you can see. I will explain again. You can see here. There are n position is there, n items or n object is there, or n student you can see. There are n places, n students you consider, suppose. So what is the possibilities there you can see, student? N student is there. First students can be n possibilities for, because n places there. The second one, first person is occupied 1 places, means remaining n minus position is there, n minus 1. Then say a third one n minus 2, so on. Rth person can be n minus r plus 1, right? So what we can do, n into n minus 1 into n minus 2 into so on, n minus r plus 1. Okay. So we need actually npr, right? So what is r here and n here? So r will be 0 to n only. R would be 0 to, so I will write here. So r would be 0 to n. You can see, so r may be equal to n or r may be 0 also, but it should be 0 to n. It should not be more than, r should not be more than n. Clear? Okay. So NPR means, P means permutation. There are n objectives there. You can select R and arrange them, right? So here we arranged up to R, right? R students, you can see n student, first n student is there, n place is there, first student n possibility is there, second one n minus 1. Then same way, if you take rth position, n minus r plus 1, right? What we can do, you have to multiply n minus r factorial and divided by n minus r factorial. So you know that this would be equal to n factorial. You know, n factorial definition is what? N factorial means n into n minus 1 into n minus 2 up to 1, right? So that would be n factorial in the numerator, denominator n minus r factorial. This is the formula for NPR. Clear? N factorial divided by n minus r factorial, that would be the formula for the permutations. Just n object is there, you had to select n also, or 1 also, or 2 also, 3 also, right? but it should be the range. R would be what? R would be 0 to n only. Suppose if there is a box, 4 balls are there, right, in the box. Okay, you can select 1 or 2, 3 or 4, or one more possibility is there, you are not selecting anything, that is also possibility is there, right? That is 0. R is equal to 0, right? The empty box, right? Nothing is selected. It will be like that only, right? Okay. So, how to understand the combinations here? So, NCR, this is a C for combinations, right? NCR is equal to n factorial by R factorial into n minus R factorial. We can see here. How we have to relate the permutation and combinations, you can see. We know that NPR is equal to what? N factorial by n minus R factorial. Clear? Okay. So, NCR, how to write? So, sorry, NPR, how to write? NCR into R factorial. Correct? So, therefore, NCR, how to write? NPR divided by R factorial. Okay, what is NPR? Just now we proved, right? N factorial divided by n minus R factorial divided by R factorial. So, you can rearrange it n factorial divided by R factorial into, right, n minus R factorial. This is NCR formula, right? Okay, just very simple. Permutation is selection plus arrangements. The combination means what? Selections only. So, NPR for permutation you can use, NCR for combinations you can use. Let us take one simple example, right? We have to understand the things very clearly. Okay. So, let's take NPR and NCR. The relation we found this, NPR is equal to NCR into R factorial. So, how this will work? We can see through example. You can see, let us take A, B and C here. Okay. Take 3 letters. Okay. So, what we can do? The first observation, you can use the permutation here, permutation and the combinations here, combinations, right? So, the permutation, suppose there are 3 letters, 3, 3P0, you are not selecting anything, right? 3P0, what is the definition? 3 factorial divided by, you can see 3 factorial divided by 3 minus 0 factorial. So, that is, what is that? 3 factorial divided by 3 factorial, this is 1. N minus R here is what? 0, right? It's 1 possibility is there. Nothing selected means that is 1 possibilities, right? Okay. So, here 1 possibilities means you are not selecting among any 3, right? That is 1 possibility. Let us take 3P1 you can take. So, what is that? 3 factorial divided by 3 minus 1 factorial, that is 3 factorial divided by 2 factorial, right? But you know that n factorial, how to define? N factorial is equal to n into n minus 1 into n minus 2, so on 1. Suppose 2 factorial means 2 into 1, 3 factorial means 3 into 2 into 1. It is same as 3 into 2 factorial also we can write, because 2 into 1 is 2 factorial, right? Okay. Then how to use this one here? You can see this is 3 into 2 into 1 we can write, this is 2 factorial, this cancel will be 3, 3P1 So that is you have to select 1. So what are the 1 here? A, B, C. These are the 3. Same way you can compare the combinations. So what is that? NC0. So that is N here is what? 3, right? You have to use this 3 here. 3C0 you can use. That is 3 factorial divided by 0 factorial into 3 minus 0 factorial. So 3 factorial, 0 factorial is 1 because you are not selecting. 1 factorial means what? 1, right? 2 factorial means what? 2 into 1. 0 factorial means you are not selecting anything, right? That is 1 possibilities. There are 4 balls in the box. You are not selecting anything. That is 1 possibilities, right? If 2 factorial means what? Right? The first will be 2 possibilities, second will be 1 possibility. 2 into 1, 2 factorial ways, right? But you are not selecting anything. That is 1 possibilities. You consider 1, right? So that is, you can see it's a 1 into 3 factorial, that will be 1. Otherwise, you can see NPR is what? What is n factorial divided by n minus r factorial? So you can put here 0. So NP0 is equal to n factorial divided by n minus 0 factorial. That is n factorial divided by n factorial, it is 1. Right? You can say like this also, right? NP0, right? Okay. Let's come to the discussion. 3C0 means only 1 possibility is there, right? That is not selecting anything. Let's take 3C1 you can take. 3 factorial divided by 1 factorial, 3 minus 1, 2 factorial. This is 3 into 2 factorial we can write. This is 2 factorial, it's cancelled. This is also 3 possibilities, right? If you select 1 and arrange it also, it's 3 possibilities only. If you're just selecting, that is also 3 possibilities, right? What are that? A, B and C. Let us take 2 at a time. You can see there are 3 letters A, B, C. You have to select 2. Any 2 you can select and arrange them. You can see the second thing is 3P2 you can see 3 factorial divided by 3 minus 2 factorial, that is 3 factorial ways. It's 6 possibilities there because 3 minus 2 is 1 factorial is 1, right? Okay. So what are the 3 ways here? 3 letters A, B, C. What are the 3 factorial ways? So A, B you can take. A, B. First you have to understand A, B, C, right? A, B, C, A, B, and then B, A. So you are arranging, right? Then B, C, A, B, B, A, right? Otherwise, you can fix B and C, C, B, and then C fixed here, C, A, A, C, right? Any 2 terms, right? So 2, 4, 6, right? A, B. So how to remember this quickly? A fixed, B and BA, arrange it. B fixed here, B to C and C to B, and C fixed here, C after A and then AC. These are the 6 possibilities. But you can compare with the combination as well. So 3C1 you can take 3 factorial divided by, so 3C2, no? So 2 factorial into 3 minus 2, that is 1 factorial, that is, what is that? 3 factorial, 3 into 2 factorial divided by 2 factorial, it's same as 3. But you have to see the difference. When you are taking the permutations, 2 at a time, there are 6 possibilities there. When you take the combination, you are taking 2 at a time, there are 3 only. Permutation 6 possibilities there, combination 3 possibilities there. What are the 3 possibilities? You can see AB, AB, and then BC and CA. These are the things. Here we are not rearranging it. We are not shuffling the things. But when you are permutation, you have to shuffle it. You have to rearrange it. You can see AB, BA, shifted, right? And BC, CB, CA, AC. It's permuted, right? Arranged. Selection arranged. But here AB, BC, CA, all are different here. There are 3 possibilities only is there. I hope everyone understand, right? Okay. Let me take one more things. If you take 3 at a time, let's take 3 at a time. So A, B, C is there. 3 at a time means 3P3, 3 factorial divided by 3 minus 3 factorial. So 3 factorial divided by 3 minus 3, 0 factorial, right? 0 factorial, just now we discussed that is 1, right? It is 6 ways possible, right? Okay, fine. Understand? 6 ways possible. So what are the 6 ways? You can see A, B, C. First you can fix the A and then arrange the next 2 letters, C, B, right? Fix B here. Fix B means A, C. Fix B and arrange the next 2 letters, C, A. Okay? And then C fixed, A, B. C fixed, arrange the next 2 letters, B, A. These are the 6 possibilities, right? Okay, this is arrangements plus selections, right? But when you take combinations, combination you can see, what is that? 3C3 you can see, 3 factorial divided by 3 factorial, 3 minus 3, 0 factorial, right? N factorial divided by R factorial into N minus R factorial. So this is same as 1, right? Because 0 factorial is 1, 3 factorial by 3 factorial is 1. So 3C3 is actually 1, right? Okay, this is combinations. You can see what are the ways you can write. 3C3 means there are 3 letters there, you can select all at a time. So A, B, C only, that is the only one way, right? Here 6 possibilities there for permutations. Here only 1 possibilities. You can see the difference. What is the NPR formula we discussed now? NCR into R factorial, right? So here you can check with the 3 letters, right? 3P3 you can see, 3C3 into 3 factorial. You check it once clearly. 3P3 is what actually? I just now got it 6. 3C3 is what? 1 into 3 factorial. Both will be satisfied. So therefore, the permutations and combinations, the relation is what? This one only. NPR is equal to NCR into R factorial. Clear? And one more information you have to remember, student, NCR is equal to NCN minus R. So we already, so we discussed in the binomial expansions, right? The first and last expression in the binomials are equidistant, right? All are same. Therefore, NCR is equal to NCN minus R. Let us take one example. Let's take 5C2 is what actually? Is same as 5C 5 minus 2, that is 5C3. Okay. I'll teach you some shortcut way to remember. For example, 5C2, they're asking, you no need to apply the formula directly. You can use the formula, suppose 2 factorial into, so what is that? 5 minus 2, 3 factorial. So this is 5 factorial. How to write? 5 into 4 into 3 factorial we can write. So 2 factorial into 3 factorial. This will be cancelled. 5 into 4 divided by 2 into 1. This is the after simplification. You can see 5 into 4 into 2 into 1. So what we can do, here suffix you can see 2 is there. 2 is there means you have to reverse 2 numbers only from the factorial, right? Because it will be cancelled. Suppose 5C2 is there means just you have to reverse 2 terms. So 2 is there means you have to reverse 2 divided by 2 into 1. That is 1 times here 2 times 10 is your answer. If I take 5C, let us take 5C, let's take 4. 5C4 is same as what? 5C, 5 minus 4. This is what? 5C1. 5C1, what you can do? One time only you have to reverse, right? 5 into 1 time, that's right. It's a 5 only possible, right? Okay, fine. Clear? This is your relations between the permutations and combinations. Okay, let us take some more example. Suppose if you have, for example, let us take using the numbers 1, 2, 3, 4, 5. Using this, using the digits, using 1, 2, 3, 4, 5, how many 2-digit number is possible? 2-digit number is possible. How many 2-digit number? So you can see the 2 digits you are collecting means it's either repeating or not repeating. The 2 possibilities there, right? The digits are repeat or not repeated. Okay, so the 2 digits means we need the 2 slot is required. This is unit place, this is a 10th place, right? Okay, you can see how to do this question. So there are 5 digits is there, 2 places only is there, right? 2 places only is there. Then what we can do? So 5 possibilities for the first place, that means 10th place, right? There is no restriction because 0 is not there. No, you don't need to worry about that. 5 possibilities there. If one of the number is placed here, that unit place can be occupied by 4 ways, right? So there are 5 number is there, 1, 2, 3, 4, 5. So any one of the 5 will be occupied in the 10th place. If one number is placed, the remaining 4 number is there, that will be occupied for the unit place. So therefore 5 into 4, it's 20 possibilities there. Clear? Okay. So in that, how many so this is actually every number is included or not? Without repetitions, 22-digit number. With repetitions, this is without repetitions. Without repetitions. With repetitions, here is 5, this is also 5. 25 number is possible with repetitions. With repetitions. Clear? Suppose using the same digits, you can see here why we are doing multiplication, counting principle. You can see multiplication principle, why we are using, because we need the how many 2-digit number, the both unit place and 10th place occurred simultaneously, both occur in the same time. That's why we are multiplying, right? Okay, suppose I slightly change the question. How many 2 digits number is possible using these digits? That case, you can see the unit place means, you can see here students, the units digits must be even numbers, right? So what is the possibilities here? 2, 4 only possibilities. The 2 possibilities for unit place, right? Okay. Here, how many possibilities for the 10th position is there? There are 5 digits is there. Okay. Remaining how many numbers you can occupy here? You can see we need only the even numbers. If one number is occupied here, 2 or 4, so here will be, so 4 possibilities there. You can see 8 even number is possible. Is it correct or not? You can check it here. You can use the addition principle here. Let us take, if I take 2 fixed here and then 4 fixed here, okay. If 2 is fixed in the unit place, remaining how many number is there? 4 number is there. Here is one number fixed, right? So 4 possibilities. We are collecting the 2-digit number end with 2. We are collecting the 2-digit number end with 4. So here 4 is fixed means there are 4 possibilities there for, right, the unit, that means 10th place. 4 into 1, that is 4. So either 2 or 4 we need actually. Whenever they are using the or here, so you have to add it. 4 plus 4, so 8 2-digit even number is possible, right? Understand? Okay. So this way we can use the counting principle, addition and multiplications, right? Okay. So let us take one simple example here. Next. Suppose if you have the grid, right? 1, 2, 3, 4. You can see 1, 2, 3, 4, 5. Let's take 6. One more column you can take. 1, 2, 3, 4. So you can start from A and end to B. So how many ways in the grid, how many ways to arrange this? How many ways to move from A to B? The shortest path, how many shortest path you can create? You can see the right, you can see how many is there, right? 1, 2, 3, 4, 5, 6. Okay. 6. You can see you had to move right 6 step. And you can see the up, you can see 1, 2, 3, 4. Up, that means north side, that is east side, right? You have to move right 6 step, up 4 step. So total how many path is there? You can see the 4 plus 6, 10 possibilities there, right? Okay. So how many shortest path you can make from this grid, from A to B? You can see there are 8, east side will be 6 possibilities, right? And north side will be 4, right? Clear? So the total 10. Out of that, the E will be 6 repeating and N will be 4 repeating. So out of that, 10 factorial divided by E is repeating is what? 4 times. 4 of 6 times, 6 times, right? E will be 6 times and N will be 4 times, 4 factorial. That is same as 10 C6 or 10 C4. Both will be same only or not? Yes. So the total number of shortest path you can make 10 factorial by 6 factorial into 4 factorial, because total path is 10. Out of that you can select 4 or 6. Correct? So why we are dividing 6 factorial and 4 factorial? Repeated things I will teach you here. Okay, let me take one more example here. Let us take A, B and C here. We already discussed that if 3 letters is there, how many, if you all at a time, if you take 3 at a time, you can take, no? So what is the permutations? Tell me. A, B, C, A fixed. A fixed means B, C, and A fixed, you arrange these two, C, B, B fixed, C, A, B fixed, A, C, C fixed, A, B, C fixed, B, A. These are the 6 possibilities. Among the 3 letters, all are distinct, right? Suppose if there is a changes, 1 letters are repeating. Let us take B, let us take A. You replace B by A only. That means wherever B is there, you can see you have to replace it A, right? A, here A, this is A. You can see, student, A, C, A, C, A, A, C, A, C, C, A, C, A. This would be same, this would be same, and this one would be same. Clear? So, if there are 3 letter is there, if you want to permute this, how many ways to permute? 6 possibilities. These are the 6 possibilities. Among that, 2 letters are repeating. The total is 3 factorial. 3 letters means 3 factorial divided by how many letters are repeating? 2 A is repeating. Therefore, 2 factorial have to divide it. Then only you will get 3 into 2 factorial divided by 2 factorial. Cancel 3 you will get. Understand? Okay. That's why we are dividing how many letters are repeating. You have to divide that many factorial. You can see here. So, east direction, right side, 6 ways there, and north will be 4 steps will be there, east will be 6 steps will be there. So, total will be 10. Out of that, E will be 6 repeating, north will be 4 repeating. You have to divide it. Understand why we are dividing? This many ways we can make, right? Shortest path from A to B. Okay. Let us take a book is there. How many ways to arrange this? How many ways to arrange? You can see there are 4 letter is there, 4 factorial. Out of that, 2 letters are repeating, right? 2 letters are repeating. Therefore, you can write 2 factorial. You have to divide by 2 factorial. Clear? Okay. Let us take one simple example. Mississippi. Let us take M-I, S-S-I, double S-I, S-S-I, P-P-I, right? P-P-I. This is your Mississippi. How many ways to arrange them? How many ways to arrange? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 11 letter is there, therefore 11 factorial. Okay. Yes. How many I is there? You can see. How many I is there? 1, 2, 3, 4 I is there. 4 I's. Then how many S is there? S's will be 2. Here is 2. It is 4 is there. And then P. How many P is there? P here is 2 is there. Right? 4 S is there. 4 I is there. 1 M is there. That is no issue. So, how many letters are repeating? So, 4 I is there, 4 factorial, 4 S is there, 4 factorial, 2 P is there, 2 factorial. Clear? So, this is the possibilities. Clear? The total number of arrangements of the Mississippi of the word, right, is there, no? 11 factorial divided by 4 factorial into 4 factorial into 2 factorial. Clear? Okay. Let me start with one more example, right? Suppose you can see what is the number of ways arranging. Let us take another example. The number of ways arranging the letter of the word, the letter of the word daughter, 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 GHTER, such that no two vowels are together, such that no two vowels are together. How to do this question quickly? So first you can see the consonant and vowels both would be there here, right? What are the consonant here? D, U, A, E, D, A, U is the vowels, right? G, H, P, R. These are the consonants, right? Vowels is what? A, U, E. These are vowels. First, which is the restriction? Restrictions on the vowels. Without restriction, you have to first fill it on the row first, right? Which is no restriction, D, G, H, T, R. But two vowels are such that two vowels together, right? No two vowels together. No two vowels. No two vowels together. That means we have to arrange it in the alternate ways only, right? Okay, where you can fill it? First you can see in the gap only have to fill it, right? How many gap is there? You can see have to fill it. 1, 2, 3, 4, 5, 6. 6 gap is there. How many vowels is there here? 3 vowels is there, right? But all 3 vowels are different, right? Okay. So there are 6 gap is there. You have to select 3 gaps. 3 gaps. Why we need actually? Because no two vowels are together. That means you have to fill it in the gap only. Because for example, A, U, E. So it is alternately filled means no two vowels are together, right? Understand? Okay. So fine. So what we can do, first without restriction you have to fill it on the row. D, G, H, T, R is a consonant. In that you have to find the gap. Alternate positions only, you have to fill it. There are 6 gap. How many gap is there? 6 gap is there. In that 6 gap is there, you have to select 3 gaps. Why we need to select 3 gaps? Because 3 vowels is there, right? You have to select it. 3 vowels is there, you have to select it, and you have to see 3 vowels are different. So you have to, among them, you have to arrange it, right? That is 6C3 into, what is that? 3 factorial ways for the vowels. Right? First you can see this is for gap. This is for vowels. 6 gap is there. You have to select 3 gaps. 3 gaps which is filled by vowel. Right? Understand? And there is no restriction in the consonants. So maybe it will be arranged, no? There are 5 different letters there, it will be arranged. So the consonants will be consonants will be arranged in how many possibilities? 5 factorial possibilities, right? Why 5 factorial? Because D, G, H, T, R is there, 5 question is there, 5 letter is there. First place can be 5 possibilities. Second place, second letter can be 4 possibilities. 4, 3, 2, 1. 5 factorial possibilities for the consonant. So you have to combine this because we need both happen at the same time. That means you need to AND. So this is the first one, this is second one. So what is that? Combine 1 and 2, what will get? 5 factorial into, why we are using into? Multiplications, because multiplication principle of counting. We need all this at the same time. Multiplications you have to use 6C3 into 3 factorial. This is the possible ways. Understand? So if you further simplify 5 factorial into 6 factorial divided by 3 factorial into 6 minus 3, 3 factorial into 3 factorial, this will be cancelled. Okay, this is 5 factorial into 6 factorial divided by 3 factorial. You can simplify this one, right? This is your answer for that question. Okay, let me take one more questions. Let me take how many ways, next question, how many ways 10 different books, let's take 10 different books, right, in 3 self, in 3 self you can take 3 self, so that no self is empty, no self is empty. Okay, this is your question. You can see how many different books is there. Books are different, 10 different books. Let's take B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, right? 10 different books. You can see 3 self. 3 self are for distinguishable, right? All are different only, right? Show that no self is empty. You can see there are 3 self is required, means how many partition is required? 2 partition is enough, right? Why? Because you can see here, you can see the thing is very simple. Suppose if you bar here, that means you divide this bar before B1, after B1, what will happen? This is your first step, this is self, this is second self, this is third self. That means the box may be empty. Understand? That means you should not put bar before B1 and after B10. You should not put bar. Otherwise, it will be empty. No self is empty. We need non-empty self. Okay. This is not possible, right? Okay. Fine. So you should not put bar before and after. Then how many bars is possible? Bar means division, right? Divide the group, right? How many is possible? 2 bars only. Let us take here 3. Let us take after B3, then after B7 you can put here. You can see this is the first slab, this is second slab, sorry, this first self, second self, this is third self, right? All are different and the box also different, right? Then how many bars you can put here? How to select it first? You can either you can put here or there or here. So first you need to understand how many gap is there, you first to find out, right? And then you have to select 2 bars only, right? Clear? Okay. So how to find out this? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9 gap is there. You should not put the bar before B1, after B10. Understand? You have to put the bar, that is division between the books only you have to put here, right? Then only the self cannot be empty, right? Okay, therefore 9 places there, you have to select 2. Why we need to choose 2 here? Because 2, for example, if I select 1 gap here, this one, and 1 gap, so you have to divide 2 self, B1, B2, B3 one self, and B4, B5, B6 one self, and B7, B8, B9, B10 is another self. It is order, right? Order wise you can see here. Understand? That's why we have to see there are 9 gap is there. You have to select 2 gaps. 2 gaps you have to fill by the bars or division, right? 9C2. This is your answer? No. What we can do? But among the 10 balls is there, no, that among that will be arranged. Maybe here B2, here may B3, here may be first place B7, whatever it is, right? Therefore, the balls among that you have to arrange 10 factorial ways. Okay. So, the answer for this question is this one. 9C2 into 10 factorial is your answer. So, 9C2 into 10 factorial. This 10 factorial arrangements of the different books, and 9C2 for the gaps. Gaps depends on the, the self cannot be empty, no? You should not select before B1, after B10. That's why we are avoiding this. We are selecting the bars between the balls, right? There are 9 gap is there. You have to insert the 2 bars. Then only we can make 3 self. Clear? So therefore 9 gap is there. You have to select 2 gaps. You have to fill the bars. You have to divide the group. So 3 groups, right? Therefore 9C2 into 10 factorial ways, right? This is your answer. I hope everyone understand this class. So next class we'll discuss the very detailed analysis of the permutation and combinations. We'll discuss the different, the number of non-negative integer solutions and binomial, binomial relations, and number of positive integral solutions, different books, different self, different books, identical self. There are many cases there. We'll discuss a different way to discuss this one, right? We can use the partition and Stirling number to identify the how to break the things, right? How to partition the things. We'll discuss using the Stirling number. Coming days, all the lectures you can watch, don't miss it. I will teach you one by one from basics to advanced level. Okay. If you like this video, please subscribe it. You share it to your friends. Thank you, everyone. Thank you.